Okay, let us start with our lecture. Uh, I guess last time we were at this particular point. That is slide number 25. Okay, so last time we discussed about uh, a problem, that is BOD problem. Uh, Now let us uh, go further for the next point. Okay, it is again a problem. Certain various types of problems are there. Uh, so the next point, again, the next problem. Okay, so the previous problem was concerned about uh, okay, this type of problem was given. So the BOD, which is at 30 degrees Celsius and 5 days, which was this one, the given. Okay, now the next point is next point is about or next problem is about like this. The problem is given. Now the wastewater is taken. Okay, so understand the problem first of all. The wastewater is taken, and after that wastewater been taken in the laboratory, then here the observation is the y 30 degree and 1 day. That means what? Whatever the observation was carried out for the wastewater which has been taken, it was incubated for 30 degrees Celsius. This is first part, and the second part is it was incubated for 1 day. Okay, so after this particular incubation, whatever the result we have got, that result is 110 degree 110 milligram per liter. So a BOD after 1 day at 30 degrees Celsius, we have got the result as 110 milligram per liter. That is the case. Okay, so this one is the first information which has been given. The second information is given, that is the coefficient. Okay, so the beauty coefficient is been there given. That coefficient is 0.23. Now that coefficient is more importantly is 20 degree coefficient. So that is why it has been written as K20. Okay, so these are the two things which are being given right now. So one thing is beauty at 30 degrees Celsius, incubated for 1 day, and second thing is the coefficient which has been given at 20 degrees Celsius. That is very necessary. And what we want is what is the result? What is this the BOD incubated at 20 degrees Celsius and for 5 days? So this particular calculation we want. Now this one would be a calculation. Okay, so the actual observation we have taken for only 1 day. After taking that observation for 1 day, and this coefficient is known to us. Based on these two things, we are going to calculate what would be the BOD after incubated at 20 degrees Celsius and after 5 days. What would be that particular BOD that we are going to calculate? Okay, got the problem. So in this manner, whenever if you are writing down, then please get this take down this problem in this particular manner. That is incubated for 1 day and K20, the coefficient we have got as 0.23. So these are the two things which have been required. Now the next part, whenever we are going for calculation, then we want is uh, we want is the K 30, because we are going for calculation of we have gone for this particular incubation, that is 30 degrees Celsius. So whenever we are going for calculation of K30, that means we have to go for calculation of that K30. Now that K30 calculation can be carried out in this particular manner. Okay, so this one is the formula. With the help of this particular formula, Whenever if you have K20, now in this particular case K20 is 0.23, just similar like our example. And if it is there with respect to base E, then K30 can be calculated. So K20 into 1.047 raised to T minus 20. Now the temperature we do have is 30 degrees Celsius. So based on that, KD we can calculate KD at 30 degrees Celsius. We can calculate as 0.364, right? The similar calculation here you can carry out, and then here you can write that particular calculation, and the result we got is 0.364. Okay, so after getting these two informations, based on this particular information of K20, we have calculated K30. Okay, now we can go for calculation of this particular BOD. So this BOD calculation we can carry out, and after carrying out this calculation, we will come to know that what is the initial BOD. Okay, what would be the initial BOD? So for calculation of initial BOD, uh, we uh, we do have this particular formula, that is y to the number of days and degree Celsius is equal to any initial that is organic matter or BOD in bracket 1 minus e raised to minus k into number of days. Okay. Now in this case, number of days is 1, k is 0.364. That is why here you get e raised to minus 0.364. Here it is multiplied by 1. So that is why it is been directly written as 0.364. So number of days is 1. That is why it would be equal to e raised to minus 0.364. Okay. So this formula, this particular with the help of this formula, with the help of this formula, it is possible for us to get L0, that is initial organic matter. Okay, at day 0. So initial organic matter at day 0, after getting from this formula, we from these calculations we get the initial organic matter as 360.53 milligram per liter. So this would be a initial organic matter being present. Okay, now the next thing what we want is this one. Okay, that is BOD after 5 days, BOD after 5 days, and at 20 degrees Celsius. So BOD after 5 days at 20 degrees Celsius would be equal to, again, that formula we can write L0 here, L0 into 1 minus e raised to minus k into 5. Now here the minus k would be this one. Okay, L0 would be this one. So based on this particular point, here the calculation we can carry out. So y5 at 20 degrees Celsius is equal to L0 into 1 minus e raised to minus 0.23, that is k, into 5. Why 5? Because we are calculating the BOD at after 5. So this one is the calculation. Just this one, just it is just a calculation. So from this particular calculation, we got get the answer as this one, that is 246.37. That is y 5 at 20 degrees Celsius. We get this particular detail. So just by the initial one day observation and some basic information, it is quite possible for us to go get the result after 5 days at whatever the incubation at 20 degrees Celsius. So in this manner, with the help of that particular mathematical model, it is possible for us to go for this calculation and go without carrying out any laboratory experimentation. We laboratory experimentation is carried out for only 1 day. So without carrying out for 5 days, we have got this particular result, and based on this result, it is possible for us to take action on it. Okay. So in this manner, we can find out the answer. So any doubt regarding this, please put it in chat. The problem you should understand, the problem is the information we have got, that is 110 milligram per liter is the we can say BOD, but that BOD is at 30 degrees Celsius and incubated for 1 day. That is the case. And second thing is that the basic requirement is given, that is constant is been k is been given, that is again at 20 degrees Celsius, that is 0.20. So based on these two factors, we have found out what would be the BOD at after 5 days at 20 degrees Celsius. Okay. So I hope that you have written that problem, and you have gone for the calculation. Based on the calculation, you get these results. Okay. So these results are been calculated now. Okay. So if you have doubts, problems, you can put it in chat. Now the next part, this one is the example. The next example we can have is again this particular example which has been given. Now the thing is that the problem given uh, the wastewater has been taken. Okay, and after taking the wastewater, then that wastewater is been incubated for 5 days. Then it has been incubated at 20 degrees Celsius. That means standard BOD we have got. We have gone for finding out standard BOD. Okay, so that is the laboratory experimentation that we have got, and the result we have got as 190 milligram per liter. Okay, and the next part is the constant. The constant is in this case generally it would be point 2 to 0.25, but again in some other cases we have got extraordinary case, we have got this K20 as 0.18. Okay, let it be. So K20 is 0.18. Okay, so these two informations are being given, right? Now what we want is if the BOD we want to find out, and that BOD again it should come out as 180 milligram per liter. The same BOD we should get, but that BOD we should get after 2.5 days. That is the requirement. So this BOD we have got as 180 milligram per liter after 5 days and 20-degree incubation. Then if we want that BOD after 2.5 days, then what would be the temperature? What should be the incubation temperature? That is the problem. Okay, so these are the informations. These information we have carried out. This is these are the details. Two details we have got. What we want is the same result we want, but that same result has to be in half day, in 2.5 days. And what should be the temperature we should keep? Okay, so that is the problem. We have to calculate the temperature now here, so that we would get that result within we would get that result within 2.5 days. Okay. Okay, so that is the problem right now. Okay, so again the problem we can go for writing down the equation. The equation we are getting, and after writing down the equation, we first of all should get L0, that is initial this one initial organic matter or ultimate BOD. So that ultimate BOD we would be getting after this writing down this equation, y pi L 20 L0 into 1 minus e raised to, again K here is 0.18, so minus 0.18 multiplied by 5. Again 5 days we got. So in this manner, the unknown factor is L0, so that L0 can be found out. So in this case, the ultimate BOD or maximum organic matter is 303.31321. Okay, that is milligram per liter. So this one is the ultimate BOD now. Now next one is our requirement. Our requirement is the same result we should get within this particular part. So in this case, we can again write down that equation for this particular situation. That is why t is unknown, 2.5, that is 2.5 days we want. So the same result, the same equation we can write for this particular condition. So we have written down the same condition here. The equation for the required condition over here. L0 is now known, that is ultimate BOD is known. Now what is not known is KT. Okay, we don't know that temperature, that is why we don't know about the constant. So this particular, first of all, constant is not known, into a number of days is known, that is 2.5. Okay, so all the known things we can put in this equation. So 180 is again the required one. L0 is known now, into 1 minus e raised to minus KT into 2.5. Okay, So with respect to that, this particular calculation, it is quite possible to go for this one, and we can find out KT. So KT we have got as 0.36. Okay. So here you can compare that K20 constant at the 20 degrees Celsius is 0.18. Now constant we have got here, but the temperature is not known. But still the constant we have got, as 0.36. Okay. So that particular after getting that constant, then we have to calculate for KT. Now for KT the equation would be K at whatever temperature we want is equal to K20, which is standard one, into 1.047 raised to T minus 20. Now this particular equation is again for calculation of constant. So this equation, in this particular equation, the known things we can put, and the unknown thing we can calculate, that is T. So T is here we can calculate from this particular this one, we get result as 35.09. This is the result we have got now. Okay. So the thing whatever was calculated, that is in this particular manner. So if we want the same result, whatever we have got the result over here, the same result if you want, then the conditions we have to get is 2.5 days we have to go for incubation, and the temperature we have to maintain is 35.09 degrees Celsius. So this particular temperature we should maintain, so that we can get the same result after 2.5 days. Okay. The same thing can be asked, that the temperature can be given, and if the temperature is given, the number of days can also be calculated. So the same thing also can be calculated over here. Okay. So depending upon the kind of requirements, we can go for the various combinations can be asked, and based on the various combinations we can go for these various calculations. Okay. So this particular part was given, and this particular part was carried out in the laboratory, and this part was utilized. This part was asked. So based on that, we have got the result as temperature, which is about 35.09 degrees Celsius. If the given sample is incubated for this temperature and this number of days, that is 2.5 days, we would definitely get the result as 180 milligram per liter. If this one L0, that is initial or ultimate BOD, if it is 303.321, if that is this one, if this much, if the BOE is available, ultimate BOE is available, then after these number of days we can get 180 milligram per liter. But this is the condition, and in this particular condition again we can get 180 milligram per liter. So again I'm repeating this thing so that you should understand those things. So whatever is been asked and whatever is been calculated, so those things you should be in a position to understand. Okay. So please do have that particular understanding, and based on that you can go for the calculations. Okay. So there would be three this one we can say equations or mathematical models. So these equations that is concerned to LT, that is the first equation. Second equation is for YT. So this equation is being utilized over here. So that is the equation, and third equation is for KT. So again that equation is been also been utilized over here. So with the help of these three equations, whatever unknown factor is there, that unknown factor we can go for the calculation. Okay. But the thing is that some initial laboratory experimentations, or some lab we can say information should be known, basic information should be known, and then based on that particular basic information you can go for the calculations. Okay. So this one is again we can say the further formulation combination equation example, and that example is been solved over here. Any doubt regarding this? We have spent a lot of time regarding the BOD itself, so that if you understand the part of BOD, COD, etc., then you won't have any problem regarding the understanding the further parts which are concerned again to the wastewater quality. So we are dealing with the wastewater quality. Okay. So this is the quality we would be going for. So if no problem is there, we can go for the further again one more problem. Now here the problem given is the 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 problem given is white maintain this one. Okay, uh, we have to go for calculation. Huh? In this case, the problem is given as the laboratory experimentation is being carried out, and again the incubation BOD been found out as 190 milligram per liter. So initially the BOD has been found out as 190 milligram per liter. That is sure. Okay, so based on this we have to find out what is the ultimate BOD. So that is very easy thing, but the one more aspect we should consider over here is K. Whenever the K is given, that K should be given as whatever figure per day. Okay, if that is factor been given, that is fine. The direct that result we can utilize over here. But in this equation we have to utilize that particular factor itself, that is constant per day. Right now the information is given that constant is given for per hour. Okay, so whenever this kind of information if it is given, then this information we cannot utilize here. So this has to be utilized, it has to be converted first in terms of constant per day. So if it is per hour, 0.01 per hour, then it has to be converted into a day. So days, 24 hours we can have. So K can be converted into 0.01 into 24, that is 0.24 per day. So K has to be first of all converted in terms of per day, and after converting that, then we can utilize in this equation. So this in this particular equation, K is being replaced as 0.24. This is the 0.24. That means what? Whatever is given, that is being converted into 0.24, and it is being utilized over here. And then the further general calculation, that is L0. L0 we have found out at 271.89 milligram per liter. That is the ultimate POE we have got. Okay, so this result we have got because of this K. Okay, 0.24. If you are utilizing this one 0.01, that won't be a correct result, because this particular equation is based on the time which is concerned to this, that is 5, that means or in terms of days. So it is not, it cannot be converted in terms of hours. So the whatever information is being given, that the information per hour it is being given, that has to be converted in terms of per day, and then it would be utilized over here. So mind it well, whenever the K is given, K has to be observed properly, that is it is given in terms of figure per hour or figure per day. So whatever the figure is there, that figure per day, if it is there, then we can directly go for this particular calculation. Generally you should observe that the K factor is there, that K factor would be in between about 0.20 to 0.25. Okay, so in that manner that K would be. So this is the general information I am giving you, but whatever the observation it is been given per hour, that per hour observation has to be converted in terms of per day, and then that has to be utilized. Okay, so in this manner, for giving that information, this equation, this problem is given to you. Okay, otherwise this type of problem we have solved already. Okay, any doubts? Okay, so this is the problem regarding the we can say uh, key, that is if we do have K in terms of some uh, other format too, then that can be given, that can be gone for calculation. Okay, otherwise the other calculations are same. Now the next problem, first of all understand the problem, and then we can go for the calculations are very easy. So the problem they have given is BOD has been determined. Okay, so the wastewater sample is taken. After taking the wastewater sample, the BOD is determined. And how the BOD is determined? BOD is determined with respect to 3 days. Okay, so observation is taken, observation or laboratory observation is taken with respect to 3 days. Now here BOD, if it is written, and even if it is a Y written, the meaning is same. Okay, so Y and BOD, the meaning is same, so that is fine. Now if this figure is written, that is the 3 days, and the upper figure is not given, that is temperature. If it is not given, then we should understand that this particular this laboratory test is been carried out at standard temperature, that is 20 degrees Celsius. Okay, so every time it is not necessary that a temperature is mentioned. If the temperature is not mentioned, that is it is been carried out at 20 degrees Celsius. That is sure. Okay, so right now what experimentation is being carried out, the wastewater is taken, and after taking the wastewater, the wastewater is incubated at 20 degrees Celsius for 3 days, three number of days. Got it? So this result we have got as 75 milligram per liter. So this is the first information we have got. Okay. Now again here K is being given. Again K, in case of K, the 20 degrees Celsius is not written. That means what? This is the standard K. The standard K is 20 degrees Celsius. The temperature is 20 degrees Celsius. So K20 in this case is given as or determined as 0.345. So whatever, depending upon the depending upon the kind of situation, we have got 0.345. Okay, so this result we have got. Now even here it is not written as per day. Whenever it is not been written, that means what? It is per day. Okay, so if specifically if it is per hour, then they would write here as per hour. Otherwise it would be a K per day. Okay, so these two things are being determined now. Okay, got it? So experimentation was carried out. It was carried out for 3 days. It was carried out at 20 degrees Celsius. The experimentation, after carrying out that experimentation, we have got the result as 75 milligram per liter, and K is 0.345. Now based on this particular factor, again now we can go for the further calculations. Now the thing was asked that what would be BOD after 10 days. That is the question. Okay, what would be the BOD after 10 days? That is the question. Now again the problem we can write over here, and we can write down the standard equation. Now the standard equation is Y is equal to L0 into 1 minus e raised to minus k into t, that is time. Now in this case the time is 3 days, no doubt. So y 3 at 20 degrees Celsius, that is equal to L0 is not known, so that we are going to find out L0 into 1 minus e raised to, now k is 0.345. Now number of days is 3, so t is 3. So with the help of this particular part, unknown factor is L0. That L0 unknown factor we can calculate. The calculation is 116132. That means what? The initial ultimate BOD, maximum BOD or initial organic matter present is 116.32. Got it? So this one is the part we have calculated. After getting this, then again now on day 3rd we have to calculate what would be the condition at day 10th, right? So again we are going to write down the formula. The same formula will write, but now in this case number of days is 10 now. Okay, so the number of days is 10. So BOD we are finding out at 10 days. Again the temperature is not written. That means what? We are incubating at 20 degrees Celsius itself. So BOD at 10 after 10 days at 20 degrees Celsius incubation is equal to L0. L0 is not going to change any condition. That would be 116132 into 1 minus e raised to again k is same 0.345 into now number of days t is 10. So BOD after 10 days, okay, BOD after 10 days is 112.627. Got it? So maximum amount of oxygen or BOD, ultimate BOD is 116.32, out of which BOD 10 after 10 days, the BOD would be, that is biochemical oxygen demand would be 112.627. Okay, so this one would be the maximum, and this is the part which is after 10 number of days. Okay, that means what? Whatever BOD remaining, that is this one is the maximum one, and this one is the been consumed after 10 days. That means what? The difference between these two is the amount which is remaining. So amount of BOD remaining after 10 days is 116.32 minus this one figure is equal to this. This is the figure which is remaining after 10 days. That means what? Whatever organic matter consumption has been carried out, and after organic matter consumption, whatever the thing which is remaining in that particular wastewater would be 3.69 after 10 days. That is the case. Bolo, any problem, any, we can say, part of misunderstanding or something like that. Okay, so first of all, you should understand the problem. After understanding that problem, then you can go for those calculations. Okay. So those calculations are easy, but the thing is that we have to go for those first of all understand the problem, and after understanding the problem, we can go for further this one. So the thing is that whatever the number of day the laboratory work is been carried out, that number of day laboratory work, after carrying out that number of day laboratory work, further things can be calculated. So with the help of mathematical model, we have gone for the further things to be calculated, to be calculation. So this part we haven't got for any laboratory work. This part we are going to have the calculation itself. So with the help of calculation, we have got this particular result. So on the day 3, because 3-day incubation we have carried out, on day 3 itself, we come to know that on day 10, this would be the condition. Okay. So in this manner, whatever the maximum BOD is there, out of that BOD, this would be the BOD which would be consumed after this 10 number of days. Okay. So basically what we are going to do is that, what is our aim whenever we are disposing the wastewater. After disposing the wastewater, then what would be the biochemical oxygen demand? Okay, so that we want to calculate. So whatever our wastewater volume is there, that wastewater volume would be discharged. After discharging the wastewater volume, how much would be the BOD? Okay, how much would be the BOD? BOD would be calculated in terms of milligram per liter, or it would be calculated in terms of kilogram. It all depends on the kind of consumption. Okay, so we are calculating that how much would be biochemical oxygen demand, so that whenever we are disposing that wastewater into the river. Okay, most probably it would be disposed of in the river. So whenever it is been disposed of in the river, how much oxygen it is going to consume of the river. That means whatever the river quality is there, that river quality water would be again in that case disturbed. And by how much quantity it would be disturbed, this part we are going to calculate. That based on this calculation, we come to know that with by this particular volume, by this particular figure, that quality of the river, it is going to disturb. Okay, so that part we have to calculate. And based on that, then we would take action that how the wastewater has to be treated, so that after treatment, proper the discharged this one quality we do have, and based on that proper discharge quality, then we are in a position to dispose that wastewater in a proper this one quality, so that it is not going to have any kind of harm to the river quality. So that is our part. Okay, so that is why we are finding out the quality, the initial quality, and based on that particular quality, we are finding out that what would be the case after number of days. Okay, and how for how many days, how many number of days that particular part, that is organic part, would be remaining in the river, so that it is going to consume the BOD. Okay, so this one for 10 number of days, definitely it is going to remain over there in the river. And after remaining for 10 number of days, what is going to happen is about 112.66 to 7 milligram per liter per BOD would be consumed per liter of this river volume. 112.6 milligram of biochemical oxygen demand, it is going to be it is a kind of demand. Okay, and till then again 3.69 milligram it is remaining. So after 1 day or 2 days, so about 10 to about more than 11 to 12 days, the whatever the disposal is there, that disposal is going to remain over there. And after remaining then after 12 days, you can say sure, the whole organic matter is there, that whole organic matter is consumed, and the amount of BOD, it would be about 116.32 milligram per liter after those number of days, after about 12 number of days. So that is the case we want to find out. And for that particular case, here there are the various combinations we are carrying out. Okay. Now in a doubt again, so please do have again, every now and then I'm suggesting you that please do have pen and paper with you, so that it would be very much easy to uh, get those to have produce your notes, and also to have the various calculations of your own. Okay. So likewise, we can go for the further things. Now the next problem again. What is the problem? The problem is that we have carried out the laboratory test. After carrying out the laboratory test, what is the result? The result we have got as 250 milligram per liter. That is the result we have got. Okay. Now the problem is, if 250 milligram per liter, if it is, if you have got after incubation for 5 days and 20 degrees Celsius, then the same result if you want. Okay, the same result if you want, then the condition we are going to put is 30 degrees Celsius. So instead of incubating for 20 degrees Celsius, we have to incubate for 30 degrees Celsius. So if temperature, if it is 30 degrees Celsius, then how many number of days, after how many number of days the same result we have got. Okay. So in the previous example, we have got the problem as the temperature we have found out. Now in this case, we are finding out t, that is time, after how many number of days we would be getting the same result. Okay. So the same calculation we are carrying out now. In case of the calculations, we um, we have to find out the details, that is K20 and K30. So in case of this one, we can find out K20. Okay. So in case of this one, K20 and K30, we can in case of calculation of K30, we can put it here. That is 1.0447 into 10 raised to, that is raised to um, 30 minus 20. So 30 is the temperature we know. So this particular K30 can be calculated, and this part of K20 we can put it over here. So based on these two, this one we can go for calculation of T. Okay. So T in this case we have got as 3.16. So if you compare these two, then in the case of this 20 degrees Celsius and 5 days incubation, then after incubation for 30 degrees Celsius and time, that is 3.16, we are getting the same result. Okay. The same equation, the same L0 we are going to utilize, right? So those things we can put it, and after putting those things, and we can have the comparison of these two things. After comparing those things, then we can get the result as this one. Okay. So right, this is the kind of similar problem which we have dealt with whenever the we have got the result for temperature. So in this manner, we can find out that particular part of finding out the number of days. So again, as I've said, the permutation combination, there are various number of permutation combinations we can go for, and based on those various permutation combinations, we can find out the details. So right now we have found out the details in this particular manner. Okay. So first of all, it is very necessary to know or to have the information of the model, mathematical models. Okay. So we are utilizing three mathematical models for L0. Then the second one is for this Y. Okay. That is basic BOD model we are utilizing, and third one is concerned to calculation of K. Okay. So these three equations, with the help of these three equations, whatever the problem may be, those problems can be solved. Okay. So this kind of conclusion we can draw. So we should know those three equations properly, and with the help of those proper equations we can go for calculations. Okay. So this one would be the another problem we have dealt with. Okay, so these are the various problems we have dealt with now. Uh, Now the we can say kind of conclusion we can draw, that is when temperature increases, organism growth increased and more oxygen is consumed, right? So again, dissolved oxygen concern, if it is there, then it is actually as temperature goes on increasing, there would be dissolved oxygen in water would be less. That is in case of water. But in case of this one, the temperature increases, organism growth increased, and more oxygen is consumed for decomposition of organic matter. So as a result, with increase in temperature, BOD also increases. That is the kind of result we can get. Okay, the same thing here. We have got. Okay, so in this case, whatever this particular part, that is as the temperature increases, the BOD increases. That means what? Here you can see the temperature 20 degrees Celsius, but the incubation time is required as 5 days. The same thing, the temperature is to 30 degrees Celsius, but the time required is 3.16. That means what? For lesser time, we have got the same result. That means whatever the BOD value is there, that BOD value would be increasing as the temperature increasing, because as more temperature if it is there, it would be more comfortable for the microorganisms, or various types of microorganisms are there, those would be active. Okay, so as the temperature is more, there will be more activity of the microorganisms, and because of that particular more activity, definitely there would be more consumption of the organic matter, and because of that particular more organic matter consumption, there would be there would be more demand of oxygen, and because of that more oxygen demand, again the oxygen demand, that is BOD, would be increasing, right? So that the more temperature if is there, the more would be BOD would be increasing. Okay, so that is the kind of result we can have. So the question also can be that prove that if the more temperature if it is there, for more temperature the BOD is more. Prove it. So if this kind of proof is been asked, then we have to go for giving the examples. Okay, so how the examples would be, and then you can have the comparisons of various results at for various temperatures, and based on the various those results, how the time required would be less. So that particular part you can explain the similar thing. Okay, the similar example means what? You don't have to give the problem itself, but still you have to give the explanation then how the BOD oxygen demand it would be more for more temperature and lesser time. Okay, so that part is been explained to you now. Any doubt regarding this one? Further, those two three things concerned to quality of water, it is remaining. So that would again require somewhat more time. So right now it is 11:51. So uh, we can stop over here. But still, if you do have problem, then we can have the discussion regarding the regarding those faults. Okay. So please do have your own this one noting down of your own, so that it will be possible for you to understand the details. And wherever you want, you can ask the details, that is how these details are, how if you're having any doubts regarding the understanding, then you can ask. So again, I've given you the concern for that is about WhatsApp. You can ask the details on WhatsApp, and you can go for the those questions being solved. Okay, so please do have that part here. And so I expect that you go through this details presentation itself, and you should have certain questions being asked. Okay, let it be. So today we'll stop over here, Those who are having problem, they can wait a year. Otherwise, they can also do. So, thank you very much.